Yeah.
Yeah. So now we are going to continue the lesson, right? Okay. Bismillahirrahmanirrahim. And Assalamu alaikum wa rahmatullahi wa barakatuhu. And good evening and Ayubowan and Vanakkam. So this is the the planning of the session, right? So I think you may have got the printouts. Those who didn't get the printout, please pull a hell after the class or tomorrow or however. Take the printouts, right? So we have divided the paper into 12 different parts, right? And out of the 12 different parts, we had discussed 7 parts. The moment of the force and the displacement time graph, equilibrium, friction, resultant force, free falling object and the momentum. So these are the theory that we had discussed. And today we're going to discuss the Newton's law and the velocity time graph and the remaining part of the question. Did you get the idea, Bilal? Those who have didn't attend the class for the previous classes, you can check the recordings, right? In the YouTube, I have uploaded the videos in the YouTube, so you can check the free marathon paper classes, right? So in that sessions, you can revise these 7 parts. Okay, today we are going to start the Newton's third law. Bilal, did you get the idea? Those who have joined for the first time, this is the plan that we are following. Okay, so last class within our 4 session, we had discussed our 7 part. Today we are going to discuss our 8th part, that is the Newton's law. And also, Bilal, we have discussed the velocity time graph. That part is also completed. Today we are going to start the section number 8, that is Newton's law. Okay. These are the questions. Question number 9, 15, 32, 41, 47, 52, 56. These are the questions related to the Newton's law. Before moving to the question, we'll discuss all the theories at once. Okay. First one, Newton's first law. Okay. So to make it easy, to make it memorize easier, I have what about the equilibrium? Equilibrium is, my dear, you know, our grade 10 unit number 12. Equilibrium under 2 forces, equilibrium under 3 forces. That is a part. If you don't have the idea, it's okay. If you don't have the idea in the equilibrium, it's okay. Because in the essay part, we have the question. All these 12 parts will be discussed in the essay part once again. All these 12 parts will be revised. Don't worry, okay? This is MCQ. First of all, Newton's first law, right? Okay. Puller, to make it memorize easily, I have divided the Newton's first law into 2 parts. Okay. Here, we'll say a ball is there. Okay. What will happen, Puller? If you didn't apply the force, what will happen to the ball? The ball will be at rest. Am I right or wrong? Until you apply the force, until you kicking the ball will be at rest. So, until an unbalanced force is applied, the object will be at rest. The object at rest will be at rest. And also, just look up to the second picture right here. The car and the box is there. Okay, both of them are moving, right? Then what happened, Puller? Suddenly the car stopped. Okay, because of the stone, suddenly the car stopped. My question is this, Puller: what will happen to the box? The car is there, the car is stopped. Okay, then what will happen to the box? The box will move with the same velocity. The box will move with the same velocity. It will be moving forward. Nothing will happen to the box, right? So again, until unbalanced force is applied, the object which are moving, the box is moving, right? The box is moving continuously. The ball will move. If you didn't get that idea, just we'll move to the football ground. Okay, here for example, just imagine you are the goalkeeper. You are the you are the France goalkeeper, right? The ball is coming towards you. You're not you're you didn't do anything for that ball. What will happen, Puller? Just you are being like this. Without doing anything, you are being like this. What will happen? The ball will move with the same velocity until you stop the ball. Until you catch the ball, what will happen, Puller? The ball will move with the same velocity. So Newton's second law says that until you apply the force, Object at rest will be at rest. An object in motion, the object which are moving will move with the same velocity. You can imagine that you are a football keeper and the ball is moving towards you. You are not doing anything. Without doing anything, you are being like this. Then what will happen, Pulal? The ball will move with the same velocity. So now you can memorize the Newton's second law easily, right? Until an unbalanced force is applied, the body at rest will be at rest. Right? And also, the body is in motion. Bodies in motion will move with the same velocity. That is the part that you want to know. Oh yeah, Spain won. Yes, yes. So you, don't remind that. Okay, yeah. Okay, yes, okay, yeah. And okay, so Newton's second law has been divided into two parts. Until unbalanced force is applied, the body is at rest, will be at rest. You can imagine a football. And also, until an unbalanced force is applied, a body in motion. You can imagine that the ball is moving towards you. You are not doing anything for that ball. What will happen, Palal? The ball will move with the same velocity. So until unbalanced force is applied, body at rest will be at rest, body in motion will move with the same velocity. That is Newton's first law. And look at these examples. Okay, here the bike and the bike rider, they are moving with the velocity, right? Then what happened? The bike stopped. The bike got stopped, but the rider, he will be moving with the same velocity. Why? The Newton said that until the unbalanced force is applied, until anybody catch the bike, biker pudikkum varangatilum, the biker will move with the same velocity. Same in the car, same in this case here. Until you catch the box, until you apply the force on the box, until you catch the box on the box of pudikangatilum, the box will move with the same velocity. Okay. Now Newton first law has been done. Okay. Newton second law. Okay. Listen here, Bula. Very, very easy. Very, very easy. Newton second law. I just say, Bula, just say. Yeah. Look at the picture right here. Here you are, one of you are applying force. Here two of them are applying the force. And here three of them are applying the force. Out of these cases, I will put A, B, C, right? Okay. Out of those three cases, in which instance does the acceleration will be high? In A, O, B, O, C, at which point does the car is going to be moved with the highest velocity?
C.
C, very good, very good. C, because we have three forces, right? So from this from this observation, you may have learned one thing, right? If the force increases, what happens, Bulal? Acceleration increases. If the force decreases, acceleration also decreases. This is called as directly proportional. Just imagine, Pulal, just imagine, right? Just imagine. You are studying well, right? You are studying well. You are studying more and more and more. What will happen to the marks? When you are studying more and more and more, what will happen to the marks?
Increase.
The marks also going to be increased. When you are studying more, the marks will increase. When you are studying less, what will happen to the marks? The marks also will become less. So this is called as directly proportional. Studying is directly proportional to marks. Why? Because when you are studying more and more and more, the marks also will be more and more and more. When you are studying less, the marks also will be less. So this is called as directly proportional. When studying increases, marks also increases. Same like that here, when the force increases, acceleration also increases. So acceleration directly proportional to force. Did you get that idea? If you are increasing the force, acceleration also increases. So this is called as directly proportional. First one, same as earlier, we have divided the Newton's second law into two parts. Then it will be easy to memorize. No, earlier we memorized like this, right? until unbalanced force is applied. Body at rest will be at rest. Body in motion will move with the same velocity. Same like that, we have divided the Newton's second law into two. Acceleration directly proportional to force. Okay. Now the second part. Now the second part. Regarding the mass and the acceleration. Well, here we have a very lowest mass, and here we have double the mass, and here we have the thrice. Okay. Out of these cases, at which instance the acceleration will be high, polar? In case A, or in case B, or in case C. Out of these instances, at which instance the acceleration will be high?
Instance A.
Instance A. Very good, Zubair, very good. Because listen here. If the mass got decreased, it happened vice versa, right? If the mass got decreases, acceleration increases. Early you may remember that one. When the force increases, acceleration also increases. When the force decreases, acceleration decreases. This is called as direct proportion. Increases, decreases. That is directly proportional. Here we are discussing regarding the inversely proportional, right? Mass got decreased, so acceleration increased. This is called as inversely proportional. And we'll say for this one, if the mass increases, we can see here the acceleration decreases. So when the mass got increased, acceleration got decreased. This is called as inversely proportional, vice versa proportional. Now come to the law, Pulal. Now come to the law. Acceleration directly proportional to force. You know that one, right? If the force increases, acceleration increases. And if the force decreases, acceleration also decreases. Done. First part. And the B part, inversely proportional. What is that inversely proportional? If the mass increases, you may remember earlier, here what happened, Pulal? Acceleration decreases. And same like here, when you're pushing a small object, when you're pushing a small toy car, what happened, Pulal? The mass will be very low, but we can push the car with the highest acceleration, right? Small toy and all, okay. Acceleration. So it happened vice versa, opposite way. Mass increases, acceleration decreases. So here, acceleration inversely proportional to mass. So this is the two laws of the Newton's second, two parts of the Newton's second law. Okay. Now Newton's third law. Newton's third law will be like this, right? Each and every action, here this is Newton's first law, and here this is Newton's second law. You can compare the pictures. Both of them are Newton's first law and the second law. Third law says that each and every action has equal and opposite reaction. Now come to the example. For these examples, okay. Here, when you're running in the the 100-meter race and all, you will be pushing the surface action. So for that action, I can turn off the mic. Please switch off the. Right, okay, we'll start the container class. Okay. Shaima, can you switch off the mic, Mula? Can you switch off the mic, please? Shaima? Can you switch off the mic, please? Okay. Right. So in the Newton's third law, what happened, Bulal? He will push 100 Newton. That is action. So for that action, we will have a reaction. That is also will be 100 Newton. So action and the reaction. So each and every action has equal and opposite reaction according to the Newton's third law. And here, when you're swimming, Bulal, you will be applying 100 Newton force, action, and here 100 Newton, that is reaction. So according to the Newton's third law, what did he say, Bulal? Each and every action has equal and opposite reaction. In swimming, same, Bulal. You will be applying 100 Newton and the water will be applying another 100 Newton towards front direction. You will be applying the force in the backward. The water will be applying a force in front. It will be push you forward. Same, Pulal. When you are working, what will happen, Pulal? You will be pushing the surface backward and the surface will be pushing you forward. Newton's third law. Okay, these are the applications. In the example, normally for the Newton's third law, they will be asking the example, the motion of the balloon, motion of the rocket, motion of the boat. In the boat, in the boat, what will happen, the engine will push the water will push the boat. You can check the paper. In the paper, in the part 2 section, you have a question like that based on the Newton's third law. We'll discuss that. Same in the gun, Pulahal. The gun will push the bullet. The bullet will push the gun backward. That's why we are keeping the gun here. We are keeping the gun in the shoulder. Because why? When you are pushing the bullet will push the gun back. When you are keeping that gun in your face, what will happen? Your face will get collapsed. Okay, be careful. Okay, now along with this idea, come to the question number 9. Okay. The incidents related to the Newton's third law. Which is the answer, Bulla? Just check the answer and tell me the answer in there.
A.
A and B. Okay. Any other answers, my dear? Any other answers? Any other answers?
A and C.
A and C. Okay. Bulla, listen here. Listen here.
All. A, B, and C.
Very good, Zahra. Yes, that is the answer. A, B, and C. Yes. Very good. And yeah, we'll discuss. We'll J1 Othniel, A, B, C. J1 Othniel, how is your fear, my dear? Is it okay now? J1?
Yes, sir.
You had a fever, right?
Yes, sir.
What about the condition now? Is it okay now?
Yes, sir. Mostly okay.
Okay. Listen here, Bilal. When you're using the O's in the boat here in the boat, what will happen, Bilal? You will be using the O's, right? You will be pushing the water backward. The water will be pushing you forward here. You will be pushing the water backward. The water will be pushing you forward. Newton's third law. Okay. And in the rocket, Bilal, same as the balloon, the rocket will be there. The rocket will be pushing the air and the air will be pushing the rocket. Newton's third law. Then come to the question, releasing the skyrocket and the oars and the air-filled balloon. All of them comes under Newton's third law. So A, B, C. So Pulahal, within the paper, now write the Newton's third law here. Every action has within the paper you can note down that, right? Every action has equal and opposite reaction. You can write the law, and under the instances you can say when swimming, and when you're walking, and that balloon, the movement of the balloon and movement of the rockets, and in the board you can write all these instances, right? Okay, first of all, write the Newton's third law. Every Pula, can you raise hand those who have the hard copy with you? Those who have the hard copy with you. Okay, 1, 5, 6, 7, 8, 9, 11. Okay, so I have shared the PDF in the group. Okay, so please take the printouts, then only it will be effective. And those who have attended the class for the very first time, the previous recordings are there, so you can get the idea. Don't worry about that one. And Swastika. Okay, Swastika, did you understand what are the mistakes that you have made, my dear? And you can write down.
Yes, sir.
Okay. Sir, last okay. I will be sending the recording there, Jeevan. Still, I haven't uploaded in the YouTube. Then after I will be sending you. Don't worry. Yeah. Fatima Manha. Yes, the answer is correct, my dear. Yeah, very good. Fine. Okay. We'll move to the
So
next.
can you explain this question again?
Yeah, fine. Simple, my simple. Newton's third law. You know the example, right? These are the examples for the Newton's third law. Here, you will be applying the 100 Newton. You will be pushing the surface. The surface will be pushing you back with the 100 Newton. Newton's third law. When you are running, even when you are swimming, what will happen, Pulal? You will be applying 100 Newton on the wall. The wall will be applying another 100 Newton in opposite direction. Newton's third law. Even in the swimming, what will happen, Bilal? When you're swimming, what will happen? You will be pushing the water. The water will be pushing you back. When you're walking, you will be pushing the surface. The surface will be pushing you forward. Newton's third law. So, according to these examples and the instances, and the balloon and the rocket, same as the balloon, rocket also doing the same thing. He will be pushing the air will be pushing the rocket. So according to these examples, the question is there, what are the incidents related to the Newton third law? In the boat, in the rocket, in the balloon, all these cases are related to the Newton's third law. Yeah, Mahal, did you get the idea?
Yes, sir.
Okay, fine. Okay, fine. Now we'll move to the next question regarding the Newton. All the laws are here, right? Okay. First law, you know the first law, right? Until unbalanced force is applied. And Newton's second law, the force is acceleration. Sorry, force is directly proportional to acceleration, and mass is inversely proportional to acceleration. You know that theory. And the third law, you know that every action has equal and opposite reaction. Well, I just try to get the idea. First of all, we'll write the Newton's every law, right? Okay. Newton first law. Under the question number 15, you may have a space there, right? So within that gap, you can write that one. I will be using another color pen for that one. And some of you are sending unwanted messages. So those who are sending the, the messages that are related not to the class, you will be removed from the class. I'm very sorry for that one. Because normally I read everyone's messages, right? So when you are sending the messages that are not related to the class, then there will be no any use, right? So please pay attention of that thing. Okay, fine. Newton first law, until an unbalanced force is applied, what will happen, Pula? Can you finish the sentence? Until an unbalanced force is applied, the object at rest.
Remain stationary.
Very good. Yes. We'll break that one into two parts. First part, the object at rest will be rest. Second one, we are going to divide into two, right? The object in motion. You can imagine the football is moving towards you. You are not doing anything. What will happen? The ball will move with the same velocity until you apply the force. After applying the force, the ball will be stopped. But until you can read the starting point, right? Until the force is applied, the object in motion will move. Will move with the same velocity.
Fourth one or second one? Answer.
You're asking the answer, right? The answer I will explain the answer, don't worry. Ah, very good, Jevan. You have sent me the low. Okay, fine, very good. Yeah, Hudayb, yes, your answer is correct. Okay. Newton's second law. What is the Newton's second law, Pulan? There are two things. The directly proportional, inversely proportional, that case, right here. The acceleration directly proportional to force, inversely proportional to mass. You may remember that. What is the meaning of that one? Eh? So we'll divide into two, same as earlier. Acceleration is first part inversely proportional to mass and directly proportional. You know the meaning of that inversely proportional and directly proportional, right? You may remember. Now one day I explain that one. Directly proportional to force. You know, if the force increases, what happens, Buller? Acceleration also increases, right? Directly proportional. But if the mass increases, what happens? Acceleration decreases. This is called as inverse, vice versa, oppositely proportional. Right, that one. Third law, you know the third law. Can anyone tell me the third law, please?
Every action has a
Every action has an equal opposite reaction.
Very good. Yes, very good. Yeah, Aki, very good. Yes. And Javon, yeah, very good, very good. And Hafsa, okay, very good. Eh? Every action has equal and opposite reaction. Yeah, Bilal, which of the law describe the force? Which of the law describe the force? First law or second law or third?
Third law.
Listen here, Bilal, listen here. You may remember under the second law, we have a separate equation for the force, right? Force is equal to mass into acceleration. You may remember from this law, we have taken or we have proved an equation. So this Newton's second law is the law who explained the force. The first law, you may say, that is not explaining regarding the force, right? Newton first law said that until the unbalanced force is applied. That is not explaining regarding the force. Second law is the one who explain the definition of the force. So here, definition of the force is explained by the second law. So within the same gap, Pulahal, you can write this equation and you can put a box. It will be needed for the today's part 2 session. Part 2 question is there, right? So when you are doing that question, this theory will be needed. This theory will be needed. At that time, you will realize the importance of this thing, right? Now just put the equation and the laws and all. At that time, you will explain. You will understand the importance. Javon, Newton's third law explains the pair of the laws. That is not the explanation. Oh, that is not the definition for the law. for the force. Because the Newton's second law only explains regarding the force and it shows the equation. Sorry, Jemon. And Akif.
Okay, sir.
Okay. Akif done.
So can you explain the second law?
You want to explain the second law? Wait. And Amra Mujib, I think the answer is wrong. I hope that we good. No, the answer is correct. Very good. Yeah. And. Yeah, fine. You want to explain the Newton's second law. Okay. Newton's second law. Simple, my dear. Don't make it hard. Okay, don't make it hard. Eh? Just look after the screen here. Here we are going to describe the connection between the force and the mass and the acceleration. Just say here we have only one force, and here force has been increased, and here force has been increased more and more. So when the force increases, what happens, Bulahal? Acceleration also increases. When I apply in the low amount of force, when the force is low, what happened? Acceleration also low. But when I am applying higher force or more amount of force, the acceleration also will be high. So this is called as directly proportional. If the force increases, mass also increases. Sorry, acceleration increases. If the force decreases, acceleration also decreases. It happens in the same way, right? So this is called as directly proportional. In another term that oppositely proportional means, inversely proportional means, just look after the picture, right? If the mass got low, what happened to the acceleration? It got increased. So in opposite way it's happening, right? And if I increasing the mass,